In this video, we are going to tackle some two-dimensional projectile motion problems using the kinematic equations we learned from the previous unit. Before we get into a problem, I must stress that the vertical and horizontal components are independent of each other. So in other words, you can't plug in a vertical component value into a horizontal kinematic equation because that will give you the wrong answer. But there is one variable that can be used for both, and that is your time variable. Now let's get into a problem. Let's say a guy jumps off his roof into his pool, which I do not recommend, and he jumped from a height of 10 meters and traveled 2 meters per second in the horizontal direction. And we are asked, what is his horizontal displacement? Before solving this problem, I advise you guys to solve for your time first, since we can use it for our horizontal and vertical kinematic equations. But like we did in the previous videos, let's jot down our given variables. So we know that our height, or our vertical displacement, is negative 10 meters. We also know that our acceleration is the acceleration due to gravity, so our acceleration equals negative 9.8 meters per second squared. And we also know that our initial velocity in the vertical direction is 0 meters per second. Since the guy is only traveling in the horizontal direction. Or in other words, the guy only has a horizontal velocity. And we know that our horizontal velocity is a positive 2 meters per second. After jotting down our given variables, we notice that we have a majority of vertical components. So looking at our vertical kinematic equations, we see that the second kinematic equation fits best to solve for our time. So we plug in the values, negative 10 meters equal our initial velocity times our time, so that's 0 meters per second, times our time, plus 1/2 times our acceleration, so 1/2 times negative 9.8 meters per second squared, times our time squared. We can simplify and we will get 10 meters equal negative 4.9 meters per second squared times our time squared. We can divide each side by negative 4.9 meters per second squared to get 2.04 seconds squared equals our time squared. And after taking the square root of both sides, we get that our time equals 1.43 seconds. And this is an estimate, by the way. Now that we know our time as well as our horizontal velocity, we remember that our velocity times our change in time gives us our displacement. So we can plug in 2 meters per second times our change in time, 1.43 seconds, gives us our horizontal displacement of 2.86 meters. In this problem, we are told a girl skates horizontally off of a staircase from a height of 3 meters and travels 20 meters down. And we are asked, what is our horizontal velocity? Well, like we did in the last problem, let's solve for our time first, as well as jot down our given variables. So we know that our height, or our vertical displacement, is negative 3 meters. We also know that her acceleration, which is the acceleration due to gravity, is negative 9.8 meters per second squared. And we know that her initial vertical velocity is 0 meters per second. we know that her vertical displacement is 20 meters. And once again, we have a lot of vertical components. So let's look at the vertical kinematic equation to see which one helps us solve for the time. After looking, we see that the second kinematic equation can help us. So let's plug in our values. So we have -3 meters equal our initial velocity, which is 0 meters per second, times our time, plus 1/2 times our acceleration, so 1/2 times -9.8 meters per second squared, times our time squared. After simplifying, we get -3 meters equals -4.9 meters per second squared times our time squared. And we can divide each side by -4.9 meters per second squared to get 0.61 seconds squared to equal our time squared. And after taking the square root of both sides, we get that our time equals 0.78 seconds. Now we're asked what is the horizontal velocity, and we know that velocity equals our displacement divided by our time. So in this case, it will be our horizontal displacement divided by our time. So our horizontal velocity equals 20 meters divided by our change in time. And this will give us a total of 25.64 meters per second for our horizontal velocity. So in recap, vertical and horizontal components are independent of each other. For instance, you cannot plug in an initial vertical velocity for an initial horizontal velocity. And my advice for solving projectile motion problems is to first find the time, then solve for what the question asks, because time can be used for both the vertical and horizontal kinematic equations. Thank you for watching this video and hope to see you next time.